Yeah, thank you very much for having me here. It's an honor to speak here. And also welcome to the listeners on the stream online. Since I'm the third speaker now, I could skip some of the introductory part, so thanks to Natalie and to you. And I thought about what application field I could choose. So we had one from industry and we had from social media, which are really interesting fields. So I chose one from the scientific publication area. But before, let me, so the title is already here. And I want to mention that I'm the one who talks here, but actually it's the work of my group of René Bernd and Hilary Farmer. And Hilary is sitting in the audience, so the lady with the red shirt. So if you have more technical questions later on, she's happy to answer them, right? Okay. Good. So we are new in Klagenfurt. So in 2019, we are the Innovation Center of Artificial Intelligence and Digitalization, and we moved to the Lakeside Park. I don't have an up-to-date picture, but there where the brownish area is, there's our office now. We are very happy to be here now and participating in the Corinthian area. And we are part of the big Fraunhofer Gesellschaft. So there are 74 institutes all over Germany and more than 28,000 employees. And we are also spread over the world. And this is not for, just showing off. I want to give it as an offer. So whenever you need somebody in the Fraunhofer area, we are also a small office, but we can get you in touch with the other institutes. We are talking about the Austrian part here. We have 4 locations now, and the one in the southeast are under my control. It's a Center of Data-Driven Design, so I liked the name of your company with the data-driven business. So it's data-driven is something which is very important nowadays, and that's why we have chosen the name. And in this Data-Driven Design Center, I skipped this one, we are dealing with a lot of artificial intelligence application fields and methods. And when we started, we organized our research work in 3 strategic projects or fields. So it's AI for text, which is the topic of today, AI for images, all this computer vision and processing pictures to get more information out of it, and AI on time series data. And also something that I read on your slides is that also for us, the combination of expert knowledge and the data-driven knowledge, the machine learning input, is very important in all our projects. So we apply these artificial intelligence know-how to different fields. So from building information modeling on the left side about forestry, logistics, automotive, and health, and also supports the scientific community. So words still have power, even in our very quick living times, and textual data still are of big importance to us. That's why we have the session here. And text has been the driving force for many years and probably will in the future. And as you see on the pictures, the history, so there's a stone of Rosetta, the library in Vienna. And on the lower picture here, you see our daily pain. So a lot of material in text has to be processed, and it's growing. It's more and more coming, and we have to think about how to deal with all the information, which are still in text form in our areas. And it's still growing. So we have the publications, we have the social media, we have the SMS, Twitter, email, Instagram. You tell me. It's still growing, and I have a teenage daughter, so I had to show off here. So too long didn't read, but still text matters to us, and that's why we set up a project which deals with scientific papers and helps to fasten up the review process. So what I'm talking about is a project, it's called SRIM, and it's something like Parship for papers and reviewers. So we are matching publications to reviewers so that they can be reviewed as good as possible. I had this slide here about the natural language processing pipelines, the techniques, but I think that I can skip it because you gave a very good introduction to this. Just point on the left side on the timeline. So it's really an old topic, or for computer science, an old topic, but still up to date and very modern. Just mentioning some of the techniques that we are using. It's lemmatization, so this grouping of inflected forms of a word into a single form so that you can deal with the formulations, or word segmentations, separating large pieces of text into single units. The parsing, which means to understand the grammar, which also hints at the more important part. So it's not just natural language processing, but natural language understanding that we want to aim at. And word sense disambiguation, this was one of the directions that I wanted to address with you. So it's still a problem. So if you have text which is dealing with not identical meanings, unique meanings, like in German, Bombenstimmung, I don't have an example for English now, it can be really different meanings because of the word bomb. So this is still difficult to deal with in text. So scientific publications are my example that I want to talk about, and I have this citation of J. Sanders. He was one of these famous tele-doctors, and he said in 1997 already that if you work through your medical literature and you read 24 hours a day for a whole year, you still would be 800 years behind, because you can never catch up with all the publications and all your knowledge. So there's really a need to learn how to proceed the text to get everything out of it. And there are more and more publications, and especially this COVID pandemic. We had so much research, and it was very important that we had so much research and results in a short time, but nobody would be able to read all the new insights and all the publications that have been written on COVID-19 insights. So that's why we need a strategy to extract the knowledge and use everything, especially in this case to develop the vaccination. So in some fields it's more like a luxury problem, but in the medical fields it can decide between life and death. And that's why we thought about how to control this peer review systems, which is part of the conference life, because you submit a paper and then probably you have already complained that it takes so long, the reviewers, they don't read my stuff, and maybe even the comments are not as constructive as I would believe. But so it's a big and long and sometimes painful process to match the papers with the right reviewers and to find reviewers who are willing to read and check the papers. So it's about SARA, Services for Aiding Reviewer Assignments, which is included in the SRM project that you can look up on the webpage. But this SARA is about how to make a good fit. So for the scientific publications processing, we use full text or abstracts of the papers, and then we do similarity research. So you were very nice to already explain what's the TF and the IDF method. So we have one more slide later on, but I go over it. It's a method of similarity you can measure in publications. We use a keyword extraction and automatic classification that you introduced, and we also use the bibliography library metadata. I cannot pronounce the word right now. And so we want to find out the conflict detection, which means that an author of a paper should, of course, not review the paper, and also the supervisor of an author should probably not be the reviewer, because you will not get a very good and objective result. So this is what we take into account. And also the expertise of the reviewer is taken into account. So not only the current position at what university a reviewer is working. So the slide before was on the paper side, now we're talking about the reviewer side. And the publication history of the potential reviewer is also taken into account. So we check what were his papers and extract the keyword and the expertise from this area. So on the recommender system that we are using here, which uses a natural language processing pipeline, it identified the conflicts based on authors and co-authors. And for every new publication, we calculate these significant features on the publication and the similarity to the reviewer text corpus, which are the features that from the second point here, from the features extraction by using the NLP on the paper. And then we order the similarities according to their importance. And the result is a hierarchy. So you get a list out of reviewers from 1 to, you can decide maybe to 5, which would be the best fit, or the best or up to 5 bests. And then you can choose, because one reviewer who's very professional, but he cannot review 100 papers for a conference. So our data sources are the DBLP, the Eurographics Digital Library, and A-Miner. So we are quite familiar in this scientific discipline, and this is what we have a lot of material here. We can't do it for the medical area right now, or for environmental pollution monitoring. So we are a little bit more focused on this computer graphics and IT area. But there are a lot of abstracts that we can fit in to teach and to learn, because we need a lot of data to train and to get the good results. And I go a little bit quicker about this. This was the term frequency that you already explained. So the number of times that the term occurs in a document. And the inverse document frequency is what we use for the weighting. So if a word occurs very often, it's not very important for us for the weight, because it might be very like and or researcher or abstract. So abstract is in every paper, so this will be a high counter, but we don't use it because it's not, it doesn't make sense. So these are the TF and the IDF terms, just as a recall. And using these parameters, we develop a ranking of the of potential reviewers for this field. I got already the warning that's why I skipped the last slide. So as a quick insight how NLP can be used for a third field of application fields, scientific publishing, is I want you to take into account that NLP supports for review assignments. It combines classical and NLP methods, and NLU for natural language understanding methods. The expertise of the reviewers is extracted from the publication histories, so we don't need the authors themselves to be a part here. So if you ask yourself, what's the difference between this and the Toronto paper matching, for example? So there the author has to be active. Here it's automatic. And so we eliminate the manual task as good as possible. And scientific publication is one field, but probably don't save lives directly with this, but it can also apply to different fields. We have projects in the legal area, because all these justice topics, everything is on paper. If you go to law, everything has to be described and fixed in written documents, and there are huge piles of documents that have to proceed. But also the applications area, like human resource is a big field, also a very yeah, you have to be very careful how to apply automatic processes here, but if you do it in a good way, it can be of support to view applications and to find the right people, the right data scientists for all your institutions. Yeah, and it can be applied to any other field where you have large documents and large groups of documents. And thanks. It's me between you and the coffee break, so...
Yeah, it's no problem. We still have time for questions because you saved some 1 or 2 minutes. So I would ask first for online. Is there no question? Is there a question in the room? Or everybody's waiting for the coffee break and then asking questions to Eva at the coffee break?
Yeah, I think...
There's one. We do one question here and then...
And then coffee, yes.
Okay.
I was just curious because there's like a lot of application for like recommender systems in NLP where bias is a really big problem. Like for example, like in application processes, I think like IBM had a struggle there because they had like a recommendation system that was like racist or very biased towards males. Mm-hmm. Did you address this issue here with this recommendation system, or are there like any possibilities here where bias can really do a lot of harm?
We are aware on this topic. That's why I said in HR you have to be very careful to rest. With scientific publications, let me answer in a different way. You always get the result from the data you put in, and if you have biased data like applications for higher positions that were mainly men, then of course it will be trained that you will search for white old men, for example, in these higher positions. For the publications, it's a little bit easier, I would say, because there's only the name, the author's name, and you have the scientific description. So this is the database that we put in, and I would think it's not biased regarding sex or race or age, because it's quite objective use of words. So yes, it's a topic, not especially for this SARA project. So I think we are on the safe side in this area.
Yeah, thanks.
Okay.
One online question, we will answer this because this cannot be done in a network break.
Okay, Xiaosu asks if there are any NLP applications in the automotive field.
Yes, but I can't tell you.
The automotive problem, always.
Yes, we are. I think I immediately get executed if I just tell the story. So.
And we record.
Yes, but no.
Okay. Maybe private email to Eva or.
I will be here in the coffee break. Then I have to leave. So.
Okay. Thank you very much.
You're welcome.